Hey, welcome. Today we're gonna talk about electricity. Electricity is a form of energy resulting from the existence of charged particles, such as electrons or protons, either statically as an accumulation of charge or dynamically as a current. Let's talk about a simple circuit like that found in a flashlight. A flashlight uses batteries as an electrical source. The load of a flashlight is the light bulb. When the switch on a flashlight is turned on, it allows electrons to flow from the source, through a conductor to the load, the light bulb. The load may also be referred to as a resistor. This type of circuit is called a simple circuit. If you use the same idea, but you had a number of light bulbs, such as a string of Christmas lights, that would be a series circuit. A series circuit allows electrons to pass through each of the connected parts in turn. Circuits can also be constructed so that the load is distributed across the circuit by two or more paths. This type of circuit is a parallel circuit. The electrical system in a house is a good example of parallel circuits. Electricity comes to a house from an electrical main which is connected to the city's electrical grid. That main goes into an electrical panel on the house, and the electrical panel divides the electricity in two more circuits that power everything in a house, from the overhead lights and air conditioner to the electrical outlets. Current measures the flow of electrons. It is measured in amps and is represented by I. Voltage is the electromotive force or potential difference between two places. It is expressed in volts and represented by V. Resistance is the opposition a substance offers to the flow of electrons. It is expressed in ohms and represented by R. Power is the rate per unit time at which electrical energy is transferred by an electric circuit. It is expressed in watts and represented by P. We can calculate power using the electrical power calculation. P equals I times V, where power is P. Voltages, V in volts, and current, I, is in amps. We can also calculate voltage using Ohm's law. V equals I times R, where V is voltage, I is current, and R is resistance. Let's look at a simple circuit like we described at the beginning. If we use an 18-volt battery to light a lamp where resistance is equal to 3 ohms, we can calculate the current. I equals V divided by R equals 18 divided by 3 equals 6 amps. We can use the same principle to calculate the amount electricity needed to power a series circuit. In a series circuit, the total resistance is equal to the sum of the resistors, or loads, in the circuit. To calculate total resistance, we can simply add up the resistance values of the individual resistors, such as R equals R1 plus R2 plus R3, etc. To calculate the total current in the circuit using Ohm's law, V equals IXR, you would first find the total resistance by adding up the resistance values of the individual resistors. Then plug it into the formula so that if R1 equals 8 ohms, R2 equals 8 ohms, and R3 equals 4 ohms, the total resistance is 20 ohms. With a 10V battery, by V equals IR, the total current in the circuit is I equals V divided by R equals 10 divided by 20. The current through each resistor would be 0.5 amps in a parallel circuit. Unlike a series circuit, the total resistance is not equal to the sum of the resistors. The total resistance in a parallel circuit is always less than any of the branch resistances. Adding more parallel resistances to the path causes the total resistance in the circuit to decrease. The total resistance of a set of resistors in parallel is found by adding up the reciprocals of the resistance values and then taking the reciprocal of the total. 1 divided by R equals 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3, as in the example above. If R1 equals 8 ohms, R2 equals 8 ohms, and R3 equals 4 ohms, the total resistance is found by 1 divided by R equals 1 over 8 plus 1 over 8 plus equals. This gives R equals 2 ohms again. With a 10-volt battery, I equals V divided by R equals 10 over 2 equals 5 amps. You could also calculate the voltage across each resistor such that I1 equals 10 over 8 equals 1.25 amps, I2 equals 10 over 8 equals 1.25 amps, I3 equals 10 over 4 equals 2.5 amps. These add up to 5 amps. Circuits can also have series and parallel components. 2 or more resistors with their heads directly connected together. and their tails directly connected together are in parallel, and they can be reduced to one resistor using the equivalent resistance equation for resistors in parallel. 1R equals 1 over R1 plus 1 over R2 etc. With all of that in mind, if we were talking about light bulbs in series and in parallel, the bulb with the high resistance will shine brighter. The bulbs in the parallel circuit have the same voltage across them, and therefore more current will flow through the bulb with less resistance. In other words, 3 light bulbs in a parallel circuit will be brighter than the same light bulbs in a series circuit. With all of that in mind, if we were talking about light bulbs in series and in parallel, the bulb with the high resistance will shine brighter. The bulbs in the parallel circuit have the same voltage across them, and therefore more current will flow through the bulb with less resistance. In other words, 3 light bulbs in a parallel circuit will be brighter than the same light bulbs in a series circuit. Because the electricity has to flow from the source through each of the connected parts in turn, if one light bulb in a series burns out, then none of the light bulbs will shine. Conversely, if one of the light bulbs in a parallel circuit burns out, the remaining bulbs will continue to shine. To recap, electricity is simply the flow of electrons, which is a subatomic particle found in all matter. We use electricity to run our cities, power our devices, and it is what makes modern technology possible. Electricity travels from source to load in circuits. We can design circuits to be in series or in parallel or in a combination of both. Series circuits are more susceptible to corruption because if one element in the circuit is blown, then the entire circuit stops working, whereas parallel circuits are less susceptible to corruption because one blown light bulb will not cause the whole circuit to stop. Additionally, with the same power source, light bulbs wired in parallel will burn brighter than light bulbs wired in series. Thank you for playing with electricity.